Hello, everybody. Today we're going to be going over limits at infinity. And you may be wondering, what's the difference between limits at infinity and infinite limits, which was the last video I did. So basically, we are going to be looking at limits whose x approach positive or negative infinity. So we're going to be looking at limits like this and how to tackle limits like that. Now, before we go over any problems, we're going to have to go over a few rules for limits as x approaches infinity or negative infinity. So we're going to write down a few, or just two main rules for approaching um, limits approaching infinity. So we'll say if r, or we'll say lowercase r, is a rational number, rational being p over q, where p and q are integer or non-zero integer values. We'll say if r is a rational number, which basically means p divided by q, where p and q are non-zero integer values. And this and c is any real number. Basically, if r is a rational number and c is any real number, we'll say the limit as x approaches infinity of c over x to the r is equal to 0. So you may be wondering, like, well, I mean, it's pretty straightforward to be honest. So as x approaches infinity, what will happen to this function right here? Of course, we know it's 0, but notice what happens in the denominator. The r gets increasingly bigger and bigger. Or rather, the x gets increasingly bigger and bigger, thus making it equal to c over, let's say, like, it gets bigger and bigger and bigger on top of the rational number as well. Thus, since the denominator is getting bigger and bigger, it will start to approach 0. And we'll also say if r is a, let's say, a positive rational number, c is any real number, and x to the r is defined for x is less than 0, so basically negative values. The limit as x approaches infinity of c over x to the r is still going to be equal to 0. So it's going to be the same exact thing as before, where r is a positive rational number, c is any real number, and x to the r is defined for x is less than 0, it will still be equal to 0. And we're going to take a look at a few examples that will go into this and maybe help to clarify these two rules for us. So we'll go first example. Example 1. Find the limit as x approaches infinity of 2x to the fourth minus x squared minus 8x. Try to do this on your own before we dive into this. Alright, so when we are tackling limits where x approaches infinity or negative infinity, the best course of action, at least for this one specifically, where it's not a fraction, is taking out the largest polynomial. So basically, the largest polynomial here will be x to the fourth. X squared is definitely not bigger than x to the fourth, and x is obviously not bigger than x squared, which is not bigger than x fourth. So I'm going to take out x4, and we are going to be left with 2 minus 1 over x squared minus 8 over x to the third. And we are going to try to find the limit of both x to the fourth, which is our polynomial that we have taken out, and our function right here that we are left with once we take our largest polynomial out. And all other limit rules also apply to limits where x approaches infinity, so you could just separate them like this. Because it'll still be equal the same. So, for this specifically, we could already say that it's infinity because, well, I mean, infinity to the fourth is still equal to infinity. We could just plug in x for infinity. But for this here specifically, we see that we're given two fraction values. So it's 1 over, wait, give me 1 second. Let me clear this up a little bit, just so we have a little bit more space to work with. But we see these two fraction values right here, 1 over x squared and 8 over x to the third. Now, as x approaches infinity, these will end up equaling to 0, because as we've stated before, our x value will become increasingly bigger and bigger, thus making the denominator very great, maybe like infinity too, yeah. So the denominator will borderline turn into 1 over infinity, or I mean, the fraction values will turn into 1 over infinity and 8 over infinity. We don't really need to pay attention to the squared and the cubed values because, well, we're dealing with infinity. So because it approaches infinity, both of these values are going to be equal to 0 because the denominator is getting bigger and bigger. So the limit for this right here is going to be equal to 2. Because since there's no x value attached to 2, we don't have to multiply with any infinity value. We don't have to plug in x infinity for x here, so it'll end up being 2. But right here we have infinity, as we've talked about before. So we are left with infinity times 2, which is just going to be equal to infinity. Let's take a look at another example. And we're going to basically be following the same rules. But actually, wait, let's go over a quick definition. if p of x is equal to a sub n x to the n plus a to the n minus 1, xn minus 1 right here, and so on and so forth until a to the 1 to the x plus a to the 0. So basically this is ordered from largest to smallest polynomial. So it'll be like x to the 5th plus x to the 4th plus x to the 3rd. That's basically what this polynomial is saying. If this function is ordered from greatest to smallest in terms of polynomial size, the limit x approaches infinity. Jeez. Oh my goodness. Oh my gosh. I'm awful at this. The limit as x approaches infinity of p of x will be equal to the limit as x approaches infinity of a to the n x to the n. So basically what this is saying is the limit of this whole entire polynomial from greatest to smallest is basically going to be equal to the limit of the largest polynomial, which is going to be right here. So the biggest limit we can take instead of just the entire polynomial right here. So because the limit is going to be exactly the same. And basically the same thing is going to be also be told for negative infinity as well. So both the negative and positive. So we'll just do this positive or negative infinity. Basically we are probing for what the highest degree polynomial will become as x approaches c. C being infinity in this case. So let's go over some examples that'll help illustrate this as well, along with our first 2 points from the beginning of this video. Okay, example number 2. Find the limit as x approaches infinity of 2x to the 4th minus x squared plus x divided by negative 5x to the 4th plus 7. Now try this on your own first before we go over it, just to see maybe if you can do it. Alright, so basically the first thing we're going to do off rip is, just like before, take out our largest polynomial, which is going to be x to the 4th. Going to be 2 minus 1 over x squared. Actually, that was fine. Plus 8 divided by x to the 3rd, I think. 8 over x to the 3rd divided by negative 5 plus 7 over x to the 4th. Alright, so before I say anything else, the reason why we took over x to the 4th was because it was the biggest polynomial, yes, but it was the biggest polynomial in the denominator. So whenever we're doing fractions like this right here, we want to get the biggest polynomial of the denominator and take it out from both the numerator and the denominator. So that is the polynomial that we will be taking out, is x to the 4th. And we could see here, we could just knock down a few. We could knock down basically all of these three because these will all end up equaling to 0. Just like with the example that we did before, as x approaches infinity, these end up becoming 0. So we remove those. And we are left with times -2/5. But remember before, where we didn't really need this polynomial right here. The thing that we were talking about before talked about taking out the biggest polynomial. So this is going to be our biggest polynomial. This is the limit of our biggest polynomial right here. So we don't even really need x to the fourth anymore. We don't have to look at x to the fourth, and it'll end up being just -2/5. Because in our definition provided before, we basically said the limit as x approaches infinity of p of x is going to be equal to the limit as x approaches infinity of the biggest polynomial, which is going to be a sub n x to the n. So this would be our entire p of x, and taking out our x to the fourth would give us our limit of 2/-5. So basically, we wouldn't really need to even do anything with x to the fourth at that point. Oh, and one more point, just a little point. I don't know why I said one more, but just to be clear, the limit as x approaches infinity of p of x does not always equal to the limit as x approaches -infinity of p of x. So these are not the same. Although not always the same. I mean, they don't always equal one another. It's entirely dependent of p of x. So just be careful on that. Let's go over one more definition, and then we'll move on to exponential values in limits. Oh, well, as x approaches infinity. So the function of f of x will have a horizontal asymptote at y equals L if either one is true. So if the limit, let's just separate here. If the limit as x approaches infinity of f of x equals to L, and if the limit as x approaches -infinity of p of x equal to L. So basically this is saying that if you are given a limit that gives you a whole value, L, basically that's going to be the horizontal asymptote at y equals L. It would kind of look like, oops. This is annoying to draw. Just, I don't know why I don't like that. Just put a red, I guess. Like how big that dot is, but basically, the point that I'm trying to illustrate is that the limit as x approaches infinity of f of x, if it equals to L, or if it's negative infinity, if it's positive or negative infinity, and it approaches L, the function of f of x will have a horizontal asymptote at x equals L. So let's say if this was I don't know, if this was I guess 4, L would be equal to 4 in this case. And since the limit as f of x approaches infinity, or negative infinity, either or, that basically gives us our horizontal asymptote for our f of x. That's basically the point I was trying to illustrate. Now let's go over just two or three like little like exponential limits, and then we will be finished. All right, so let's go over. Let's just do a few exponential value limits. So we'll do y like that, infinity e to the. Okay, this might seem a bit ridiculous, but I'll walk you guys through on how to handle these limits, because you might see them in a textbook or something. So for limits like these, where we're given exponential value and then we're giving some big, like I guess power right here, and you might be confused as to like where does this where does this value go? Where does this function end up like going towards as x approaches infinity? Um, and for these kinds of problems, we want to isolate the power value, which is x to the fourth minus 5x to the second plus 1, by itself, and find the limit of that. So we'll do the limit as x approaches infinity of x to the fourth minus 5x squared plus 1. So basically this is going to be equal to infinity because, well, um, if we were to take the biggest value, it just really wouldn't make any sense. I mean, it's very obvious because the biggest value is x to the fourth, and well, as x approaches infinity, these values will become pretty minute and pretty small. So we'll just end up just with infinity. And yeah, basically since it's infinity, now we can go to we can literally just replace this with infinity. So it'd literally just be e to the infinity. As x approaches infinity, this is going to approach infinity as well. And this is just going to be equal to infinity. But if it was negative infinity, like say if it wasn't x to the fourth, for example, let's say it was like x to the fifth, right? And it was minus 5x squared plus 1. And as x approaches infinity, this would basically be negative infinity. And then we'd be given e to the negative infinity. But if it was e to the negative infinity, that would just end up equaling to 0, because anything with a negative exponent is just going to end up going on the denominator. So e to the negative infinity would just end up equaling to 1 over e to the negative infinity, which would equal to 0. But in this case, since x isn't negative and isn't to an odd value, like to the fifth, this limit right here is just going to be equal to e to the infinity or infinity. And that will be it for today. And I'm going to be going over some programming stuff soon. So keep an eye on that. I mean, not like I have any views on these videos, but you know, yeah. Regardless, thank you for enjoying.